Okay, so we talked about alternate interior angles. If you remember, the alternate interior angles are the ones that are on the interior and they're on opposite sides of the transversal. Alternate interior angles are something that can be seen to be congruent. Oh, that's not a pen. Let's try that again. Congruent, meaning they are equal. Exterior angles, alternate exterior angles, are these ones that are outside on the exterior of the parallel lines and on opposite sides of the transversal, and they are also congruent or equal in measure. Same side interior angles are the only ones that are really different. They're on the interior again, but they're on the same side of the transversal. They are not equal in measure, not usually. They are supplementary, meaning they add up to 180 degrees. Lastly, we have corresponding angles, which are on the same side of the transversal, but one's on the interior and one is on the exterior. These are congruent. So for all of the angle pairs that we talked about today, you have a whole bunch that are congruent, but same side interior angles are the ones that are different, and they are not congruent, but their measures add up to 180 degrees. So let's try some problems. You have your worksheet from class, and we have that the measure of angle 1 in this diagram is 115 degrees. You're supposed to be able to find the measure of all the other angles. Well, if I know that, then I can find the measure of angle 4 directly across as 115 degrees, because those are vertical angles. So the measure of angle 4 equals 115 degrees. It's vertical angle with angle 1. Then I can see that the measure of angle 2 is 65 degrees. I know that because these angles have to add up to 180 degrees. So if I take 180 minus 115, then I get 65. So the measure of angle 2 is 65 degrees. I also know that 2 and 3 are vertical angles, so this is also 65 degrees. So the measure of angle 3 is also 65 degrees. Now we need to jump down to this other, all the angles along this other intersection point, 5, 6, 7, and 8 down there. And I have to use my parallel angle properties to get down there. So you can see that, for example, angle 1, which was our given angle, is a corresponding angle to angle 5, which means that they're congruent. So the measure of angle 5, the measure of angle 5 is also 115 degrees. Well, if I know that that's 115 degrees, I can use exactly the same method to find the other angles. So measure of angle 8, which is directly across, is also 115 degrees because it's a vertical angle to the measure of angle 5. Lastly, we need to find angles 6 and 7. I'm going to do that the same way that I did originally by using the idea that this whole angle is 180 degrees. So subtracting 115 from 180, I get that the measure of angle 6 is 65 degrees. So the measure of angle 6 is 65 degrees. And lastly, I'm going to use vertical angles again to find that the measure of angle 7 is 65 degrees. Okay. So now we're ready to start with question 4 here. Question 4 will require a little bit more work, but it operates on the same principle of our previous one. Let me make a little bit more space here. Okay, so now we have a little bit more space. I've redrawn the diagram here. In this problem, we see that the measure of angle 3 is 3x. So I'm going to come over to to angle 3 and write in 3x. I also have that the measure of angle 7, sorry about that, let me try that again. The measure of angle 7 is 4x minus 24. So I'm going to write that in as well. So angle 3 and angle 7, we need to find some relationship between those angles. Can you remember what they're called? These two angles are on the same side of the transversal. One's on the interior, one's on the exterior. These are corresponding angles, and corresponding angles are congruent. So I know that angle 3 is equal to angle 7. I'm going to write an equation. And now I can solve this equation for x. Oh, that's probably not the most efficient way to do it. Let me try that again. That would have worked, but it's not super efficient. I'm going to subtract 4x from both sides, and I get negative x equals negative 24. In other words, x equals 24. That's good. It's not actually doing what I'm supposed to do. I'm supposed to find the measure of every angle within the diagram. X is equal to 24, so what that means is that angle 3 over here is 3 times x. So instead of looking at it as 3x, I can look at it as being 3 times 24, which is 72. If that's 72 degrees, then I know that angle 7 is also 72 degrees. I'm going to just fill in all of the 72 degrees. This angle is a vertical angle with angle 6, so it's got to also be 72 degrees. Likewise, angle 3 is a vertical angle with angle 2, so that's also 72 degrees. Angle 1, well, it's a linear pair with angle 2, so they form 180 degrees altogether, so this must be 108 degrees. Now I'm going to use vertical angles to find out that the measure of angle 4 is also 108 degrees. And you can think of alternate interior angles being formed here between 4 and 5. So angle 5 is 108 degrees as well. And vertical angles with angle 8, this is also 108 degrees. So there you've got it. We've found every angle within this diagram using our angle properties. So you should have finished section B by now. And you're supposed to do section C. I think that this should be pretty straightforward. The only one that might cause you trouble, I think, is number 12. And you shouldn't actually have to do too much before you can solve that. In fact, I think you can solve it straight away. So let's look at that. In the statement of this problem, they tell you that NO is parallel to ML. I'm going to mark that by putting an arrow on each of those segments. The measure of angle LNO is what we're after. Let's see. I think I have to use parallel lines somehow because the angle that I need is right up here, and how am I ever going to find that? Well, one thing that seems useful is that idea of having the parallel lines. So let me draw those in a little bit differently. You can see that, what's going on here? You can see that we have one line here, we have another line here, well, if it's going to draw, there it is, and then we have our third line, which is a transversal, and it's right through here. There it is. Let's see if I can get it on the line. There we go. So that's our transversal. Some of you might be able to see right now how the angle that I've colored blue is related to the angle that's down here. These two lines are on opposite sides of the transversal, and they're both on the interior. So they're called alternate interior angles. And you should remember that alternate interior angles are congruent. So the measure of angle LNO, which is here, is also 22 degrees. So I'd like for you to finish this problem as part of your homework. You're going to use what you know about triangle sums as well as what you know about parallel lines in order to finish that off. And that's the end of this video. Please finish this worksheet as well as the other worksheet that I've posted on the blog. Thanks.